السلام عليكم أعزائي الطلاب. محاضرتنا اليوم الأولى حول موضوع compressible flow، الجريان الانضغاطي. الجريان الانضغاطي هو الجريان الذي يحدث مع تغير الكثافة. A compressible flow is that flow in which the density of the fluid change during a flow. All real fluids are compressible to some extent, and therefore their density will change with change in pressure and temperature. It means that all fluid or gases can be assumed or considered as compressible because their density will change with change in pressure and temperature. If the relative change in density is very small, the fluid can be treated as incompressible. A compressible fluid, such as air, can be considered as incompressible. It means rho equal constant if the change in elevation is small and acceleration is small and the change in temperature is negligible. In other words, if Mach number is small. What is Mach number? Mach number is ratio of the fluid velocity to the sonic velocity at the same temperature. It is denoted by m. M equal V by C, where V is the fluid velocity and C is the velocity of sound, sonic velocity. The gases are treated as compressible fluid, and the study of this type of flow is called as gas dynamic. So this branch of science in engineering or mechanical engineering is called gas dynamic. The study of compressible fluids is called gas dynamics. Some important problems where compressibility effect has to be considered are the problems that affected by compressibility or treated as compressible or fluid or gas dynamic is or are. They are flow of gas through nozzle, orifice, the compressors, flight of aeroplanes or projectiles, moving at higher altitude, water hammer, acoustic, and there is more problem can be rated as compressible flow problems. The basic principles in compressible flow are conservation of mass, continuity equation, Newton's second law, the momentum equation, conservation of energy, first law of thermodynamics, entropy principle, second law of thermodynamics, equation of state, velocity of sound pulses in a fluid. At first time of this section, we can define the velocity of sound in gases and how it is determined. Infinitesimal pressure wave is initiated by a piston movement to the right, figure 1 in a pipe of uniform cross-section. The pressure wave front propagated steadily with a velocity c, which is now known velocity of sound, sonic or acoustic velocity. The fluid near the piston will have a slightly increased pressure and will be slightly more dense than the fluid away from the piston. Then the fluid near the piston has high pressure and high density near the fluid away from the piston. To simplify the analysis, let the fluid flow steadily from right to left, and as passes through the wavefront, the velocity reduced from c to c minus dv. At the same time, the pressure rises from b to b plus dv and density from rho to rho plus d rho. This is the figure. As the piston moves to the right, the place near the velocity near the piston become high pressure and high density, but the velocity be small. So at the front, the velocity is c, and at the piston, the velocity c minus dv. By applying the continuity equation for the control volume gives rho AC equal rho plus d rho into A into C minus dV. The change in velocity is dV. By cancelling A, it becomes rho C equal rho plus d rho into C minus dV. By opening these two brackets, by multiplying these two brackets, we can get rho into C equal rho C minus rho dV plus C dV, C d rho plus d rho into dV. Rho dV equal, by cancelling rho C, it become like that. Neglecting the product d rho dV because it is very small as compared with other. Then we can get rho into dV equal C d rho. This is equation number 1. The momentum equation for the control volume gives B minus B dB into A equal m dot into C minus dV minus C. And simplifying this term, we can get rho into A into C equals C minus dV minus C, or minus A dB equal minus rho A C dV, or dB equal rho C dV. From equation 1 and equation 2, we get that dB equal C squared d rho, or C equal dB by d rho under the root. This change in pressure and density is very small and occurs very fast. It can be assumed as adiabatic with no friction and viscosity. Then C equal under the root dV by d rho at constant entropy. For ideal gas in an isentropic process, BV to power k equal constant, or B by rho k equal constant. By differentiating this equation, we get that 1 by rho to power k dV by d rho minus k B by rho to power k minus 1 equal 0. By multiplying this equation by rho to k to power k, then we get that dV by d rho equal minus k equal k into B by rho. From equation of start for ideal gas, BV equal RT or B by rho equal RT. Then dB by rho equal KRT at constant entropy. So dB by d rho at constant entropy equal KRT. By substituting in equation 3, we get that C equal under the root dB by d rho at constant S or equal KRT. Thank you. Okay.